This lesson is on density. It's a follow-up on lessons that had been done with a co-teacher that she had already introduced density and the formula for density, had worked on the students with volume and mass. So I'm following up just to try to explore further into density and also try to get them to make some relationships with density and water. So um, that's the activity that they're about to be involved in.
Calculate for all matter. And so when we're describing it with this suitcase, the whole demonstration is this. The more tightly packed that it is, the higher the density is. So this suitcase over here has got more stuff packed in it. It has a greater mass for the exact same volume, therefore the density is higher. All right, so moving on from that, what we're going to talk about, moving on, it has to be recorded. Are you okay? Falling out of your chair?
With an eye.
Okay. Please don't touch the things until I tell you to. Alright, so there's the formula we've been talking about. Density equals mass divided by volume. So today what we're going to do is we're going to be finding out what is the density of each object. Remember that all of our scientific inquiry begins with questions. So our questions are going to be to find the density of each object using the equation. So you'll first have to find the what?
The mass.
Mass. How might you find the mass?
With the triple B balance.
The triple B balance. Then you're going to have to calculate the volume. Our atoms are going to be irregular shaped atoms.
Like how much space is there?
Right. So our best way that we're going to calculate volume for these atoms is I'm going to give you a graduated cylinder, and you're going to have to drop them in the water. And remember how we did that? We took the atom, dropped it in the water, and saw how much it displaced the water. So we took the before and after measurement of how much water, subtracted to get the volume. So we've done that before, but I'll help you as we go along.
You don't need some help. I think so.
Okay. If we can't be serious, remember, we're going to fall flat holes, we're going to be gone. Okay? I have an ulterior assignment. Okay? All right.
There I had to correct a couple of students that were kind of acting up and just trying to redirect their attention to what we were doing. And then I'll let you watch some more before I tell you what I did wrong next.
So then we're going to see how will that affect it in the water. So after you've calculated the density, I want you to make a prediction. Your prediction is going to be, is this item going to sink or float? Once you know the density. Then you're going to drop it into some water, see if it sinks or floats. Okay? Now, those are the questions we'll be asking.
Okay, that was kind of redundant and silly, and this was the first time I taught this lesson. And the next class, of course, I realized what I was doing was kind of silly because I was having them calculate the volume with water displacement and then having them find out if it sinks or float, which they already know because they had to drop it in the water to find the volume. But the main thing here was for them to, and the overall goal was accomplished. They were able to calculate the density and make the relationship with the density of the object and then how it reacted in the water, whether sinking or floating. But yeah, I had to totally revamp that. So here we go.
Ourselves today. And then, let me show you the next part. Takes a while. Alright, there is a program on the iPads that you will be utilizing. It's called Poplet. Yes, sir. Yes, sir. It's called Poplet. It's really easy to use. Yes, sir? No, you stay right there. Now, yes, sir. On Poplet, I'll show you, I'll come around and help you as we're doing this. But it's so simple to use. You only have to touch the screen, it opens a box, and you can start typing it. And then you can connect the boxes. And you notice I did one here. I misspelled marble, I put marble. So anyway, you're going to put a marble, so you're going to calculate the density. Notice I have the density formula next to it. Put your answer up above it. And then below, I want you to write whether it floats or it sinks, okay? So you're doing doesn't float or doesn't sink. So you can put your data into the Popplet. If you don't like doing it in Popplet, you can just use EduCreations, okay? And just make it in the slideshow, and I'll show you how to do that in a second. All right, so then after that,
Okay, this was the first time that they had used Poplet. I really should have had them use Poplet probably the day before, just so they were familiar with it, just to let them play around with it. And that way I wouldn't have had to show them the example, because as we know, students see that example and they try to recreate exactly what you did. Of course, I didn't have the actual data in there, but they try to set theirs up just like mine. Even though I didn't keep the example up there, I quickly shifted to the next one. They still, wanted to just match exactly what I did, and I really wanted them to just get their data down and try to make the connections, using that organizer. But so next time, that's what I would do. I would first let them have a day of just kind of messing with Poplet and making different mind maps and organizing their thoughts so that they would be familiar with it.
then we're going to ask ourselves what we think water's density is. So we'll already have the density of all these different objects. You will notice some will sink, some will float. All right, so I want your conclusion to be, what do you think that means about the density of water? So after you've collected all your data, you're going to try to make a conclusion that would tell me what you think the density of water is, now that you know which ones sink and which ones float. Any questions about kind of what you're doing right now? Now, we're going to start by just calculating density for all these items. I will assign one person to be in charge of taking pictures for your group, all right? And then I'll come around and I'll give the iPad to a different person in your group. If you're the person in charge of the iPad, because we're dealing with water too, you have to be up and away from the table. You cannot sit down, you cannot come over to the table and put your iPad down. You have to be up and taking the pictures and walking around, making sure you're getting good photos of what everybody's doing.
The next lesson, I did not let them take pictures. Now, they love that. They love taking pictures of their group as they worked, and really motivated the ones to work that were working to really work hard as the pictures were taken of them. But I think that the student that was taking the pictures at the time was missing out on some key information that was going on in the group. So the next time I did not allow them to do that. Now, instead, of course, at the end of the lesson, which you're not going to see, I let them videotape themselves talking about what they learned and what they understood about density and what new discoveries they made about the density of water. And that was great. They loved that. It took a whole class period to do that, but they really enjoyed that, and I really think they understood it because, like, everybody wanted to be a part of the video. So the kids that maybe didn't get it in the lab, their teammates were really making sure they understood, talking to them, so that when they got on camera, they would make sense. So that was very beneficial. But taking the pictures during the lab was a bad idea, and I nixed that on the next time around.
Okay? And then whenever I come around, because I'm going to come around and help you to put it into the program, then I'll give it to somebody else and it'll be their turn. So I'm going to try to make sure everybody gets a chance to use it. Okay? If you're not the person with the iPad, I want you to be working on at the table, not going over there and helping them. If they need help, they need to ask me. Okay? Alright? So we're going to start with, you've got your triple beam balances. If you are sitting on this side of the table, I need you to get up and come here so I can give you your next supply.
I'm not on your table. I'll go get it. I'll go get it. I'll go get it.
If you're sitting on the side of the table that's closest to the window, I need you to come here and help me. That's all.
Don't come in me. There's water.
The lesson went really well, and I think they got a lot out of it. It was great practice for them in doing the density formulas, and then also it was a great conclusion for them to come to see how the more dense an object was, how it would sink, and the less dense it was, how it would float. And then they were able to make fairly good conclusions about the density of water. They had a range, but they knew it was somewhere. I think I have an example in a different slide I did that shows where they said the density is somewhere between 0.76 and 1.23, and that's because they knew that 0.76 was floating and they knew that 0.1 whatever was sinking. So I mean, I know that it went well because they came away with a better understanding of density, a better understanding of how to calculate density, and also just how to use the triple beam balance and how to calculate the volume of an irregular shaped object. So they came away with a lot, and definitely there were some changes though that I will make next year.